All right, we are going to be doing lesson 7.2 today. You will definitely want your green paper with all of your trig identities on it. They're going to be super important. And so I want to show you the type of problem we're going to be dealing with, and then we'll come back to all of these things. But we want to verify that this whole mess on the left side is actually equal to 1. So basically we're trying to show that the two sides of the equations are in fact equal. Okay, I kind of like these problems better than the simplifying ones because you know when you're done. You need the left side to look like the right side. Okay, so some guidelines for working for this. You want to work with one side of the equation at a time. Usually you want to start with the more complicated side and see if you can get it to simplify down and then maybe work with the other side. Some tools that you have, you can factor, you can add fractions, like if you've got two separate fractions, you can get common denominators and put them together. You can try squaring things, a binomial. That's a dangerous one. We'll talk about that. Or like rationalizing the denominator can be helpful. Look for opportunities to use your fundamental identities. Okay, your Pythagorean identities. Pay attention to those. Your reciprocal identities. Sines and cosines tend to go well together. Secants and tangents, cosecants and cotangents when you're looking at the Pythagorean identities. One strategy that sometimes works is if you just change everything to sines and cosines. Sometimes that's really helpful because then things cancel. That doesn't always work, but it is something you can try. The most important thing is to try something, okay? Don't just look at the problem and be like, I don't know where to start. Just try something. If it's wrong and it makes it more complicated, then you start over, okay? Or you might do something wrong, you're like, oh wait, this is wrong, but I can kind of see if I had done something different, it would get me somewhere good. The most important thing is to just keep trying these, okay? They take practice. It's like a little trig puzzle, so they take practice. Now, the last important thing, I want to be really, really clear about this. You do not know that the two sides are equal. I know there's an equal sign between them, but they're saying we want to prove this is equality. You're trying to prove this equality. We don't know it for certain. So we cannot add or subtract things to both sides of the equation. We can't multiply or divide both sides of the equation by something. You have to work with the left side of the equation separately from the right side of the equation. So no crossing stuff over because we don't know that they're equal. That's what we're trying to prove. All right, let's dig into this. So we want to verify that sine squared theta plus cosine squared theta over cosine squared theta times secant squared theta is in fact 1. So we're going to take our first bit of advice is we're going to work with the more complicated side, which clearly is the left side. So hopefully this jumped out right at you at the beginning. Sine squared plus cosine squared, that's one of your Pythagorean identities. Sine squared plus cosine squared equals 1. So you can replace that entire mess with 1. So 1 over cosine squared theta, secant squared theta equals 1. I also want to encourage you to only do one step at a time. You need to show your work all the way through this so that someone else can come along and read and understand exactly what you did, okay? Don't combine a bunch of steps into one and be like, do not come to this problem and be like, 1 equals 1, done. You haven't shown anything, okay? Don't do that. All right, let's keep going. Sorry. Let's see. So we have 1 over cosine squared times secant squared. Cosine and secant, those are reciprocal functions. Hey, there's the bell. So cosine squared theta, I'm going to change secant squared to 1 over cosine squared theta. Okay, that's just a reciprocal. And then notice down here, do you see these fractions here? See how the cosine squares are going to cancel? And I get 1 over 1 equals 1. 1 equals 1. Now I'm done. Okay, and I've showed all the steps for how I got there. All right, let's check out another one. We want to verify that 2 cosecant squared beta is equal to 1 over 1 minus cosine beta and 1 over 1 plus cosine beta. We're going to take our advice and work with the more complicated side first. So that's the right-hand side. I don't see any Pythagorean identities. Nothing's squared, so we can't use any Pythagorean identities. So I'm thinking maybe since the left-hand side is just one term and the right-hand side is two terms, that maybe we should combine these two fractions. So that's what I'm going to try. I'm going to common denominator and combine these. So my common denominator is going to be 1 minus cosine beta, 1 plus cosine beta. So I need to multiply top and bottom by 1 plus cosine beta. And then this one I need to multiply top and bottom by 1 minus cosine beta. Okay, so that makes my numerator, now, normally you have to distribute that 1, but it's just a 1. So we get 1 plus cosine beta plus 1 minus cosine beta. And the denominator is 1 minus cosine beta, 1 plus cosine beta. Over here, I haven't done anything with this side. I'm just going to leave it alone. Okay, I can simplify this. Cosine beta and negative cosine beta cancel, so I get 2. And the bottom, I'm going to FOIL that out. And I'm really excited about FOILing it because I can tell right now that some stuff's going to cancel. So I get 1 plus cosine beta minus cosine beta. I'm not going to write those both down because they're just going to cancel. And then minus cosine squared beta. I have not done anything with this side. Just leave it alone. Okay, now when I look at this, aha, I see a Pythagorean identity here, right? We know that sine squared plus cosine squared equals 1. So if I subtract the cosine over, 1 minus cosine squared beta, I can replace 1 minus cosine squared beta with sine squared beta, which I'm going to do that. So we have 2 over sine squared beta. I haven't done anything over here yet. All right, how much space do I have here? Not very much. Let's see. I think I'm really, really close. This is the same thing. You may be able to see this right now and just take one more step, but I'll break it down for you. This is 2 times 1 over sine squared beta. I still have not done anything here yet. And then 1 over sine squared beta, if you use a reciprocal identity, that is cosecant squared beta. And I have not done anything to the left-hand side, but I have arrived. I've proven that identity. All right. Now, I did it this way. If you did slightly different steps and still got the same answer, like if you had changed the left-hand side to 2 times 1 over sine squared beta and got it that way, that's okay. There's more than one way to solve these. I know this is a long video, but let's go ahead and knock out number 3. We want to verify that secant squared x minus 1 times sine squared x minus 1 is negative sine squared x. I don't think I want to FOIL this because secants and sines do not pair very well. But I want to look at this thing. One of my Pythagorean identities says that sine squared plus cosine squared equals 1. Now I have sine squared minus 1, so if I pull the 1 over here and move the cosine over there, yeah, that might work. So I'm going to replace sine squared minus 1 with negative cosine squared. All right. On the other side, I don't know if, does that look like one of the Pythagorean identities? It does look a little bit like Pythagorean, 1 plus tangent. Can we get that to do something? Yeah, let's try that. All right, now let's look at this thing. Do a different color. This one's making me kind of think of the other Pythagorean identity that we had. 1 plus tangent squared x equals secant squared x. And if I subtract the 1 over, tangent squared x equals secant squared x minus 1, I can replace this with tangent squared x. So we have this times this. Okay, so I've used two of my Pythagorean identities. Okay. Tangent squared. Notice I've got cosines and sines. We can rewrite tangent in terms of sine and cosine. Remember, tangent is sine over cosine. So tangent squared is going to be sine squared over cosine squared. And then I have negative cosine squared, which I can put that over 1. I haven't done anything to that side of the equation. I'm just going to leave that alone. And then, oh, this is fantastic. Cosine squareds, they're on the diagonals. They will cancel out. So I get negative sine squared equals negative sine squared. And that's done. Okay. If you look at the notes, the PDF notes that I posted of this on the other link, I solved it a different way on that. So again, there's more than one way to do these. They take practice, but we'll see some more examples on the back side of the notes in the next video.